Hello. Today we are going to talk about the pulse mode and a continuous mode. Okay. So, um, our team members, it's me, Manuel Ordóñez, Samuel Cotera, Sergio Berreyesa, and Roberto Blanco. Okay. First, we are going to take a look at the diagrams for the continuous mode and the pulse mode. As we can see, for the for the continuous mode, we just have our DC voltage source, which in this case, this is a battery, which is connected a resistor, and then we have an LED. Okay, this is a real simple diagram where we have here a switch. When we press that switch, the circuit is going to be a closed circuit, so there is going to be a current flow through the resistor and through the LED, and this is going to light to turn on. When we press again the switch, this is going to be an open circuit, so there is no current flow in this circuit, so the LED is going to turn off. Okay, so here we have now the the circuit for the diagram for the pulse mode. Okay, here we are going to use a transistor, an NPN transistor, and we have an LED here. What is the difference between these two diagrams? Well, we have the LED, which is always connected to a DC voltage source. It could be a battery or anything. But also we have here our transistor, and our transistor is going to get us any signal from everywhere we want to. Okay, in this case we're going to use a microcontroller, which is going to give us 5 voltage or 0 voltage. Okay, a one or a 0. Okay, we have two resistors, we have the LED and our transistor. Now we are going to find the values for the resistors. Okay, so basically this is a transistor, and this circuit is the same. So this transistor is going to work as an interrupt, okay, as a switch. Why? Because here we have the emitter and the collector for the transistor, and this is the base. Okay, so our transistor, or the transistors, have a saturation voltage. Okay, when this saturation voltage is reached, there is going to be a current flow through the base and the collector, and this is going to be an open a closed circuit. Okay, so the transistor is going to work as a switch. Okay, now we are going to use our red LED. So we are going to find the data sheet for this LED. Okay, here we have the LED. The forward voltage, which is the one that we are going to take a look. Here we have, it's 2 volts, and current, it's 20 milliamps. Okay, 20 milliamps and 2 volts. Okay, so now we are going to find the the resistor, the value of the resistor for the LED. Okay, so we have the LED, which it's 2 volts, and it also has a current for 20 milliamps. So for the resistance, we know that applying Ohm's law, we know that it's voltage divided by the current, okay? But in this case, we are going to use a 9 volts source, okay? So it's going to be 9 volts minus 2 volts divided by 20 milliamps. We get 350 ohms. But there is no commercial value for this resistor, so we're going to use a 330 ohms commercial resistor, okay? So that's the value for the resistor that we need for our LED. Now, to find the current through the LED, we apply again the simple Ohm's law. Okay, we have the 9 volts, which is our source, minus the voltage for the LED divided by the value for the resistor that we just found, and then we get a current for this value. Okay, and now we are going to find the value for the other resistor. Okay, here. For this resistor, for the resistor for the base for the base of the transistor. Okay, because if we take a look at the datasheet, we are going to use 2N 2222. Okay, so for this transistor we get here, okay, here is the value. The base emitter saturation voltage, it's 0.6 amps volts. Okay, and we get, and we are going to and we are going to and the gain for this transistor, the gain is 50. Okay, so that's the value for our transistor, it's 50. Okay, so again, to find the resistor, again, we just apply the Ohm's law, which is the source. In this case, we are going to use a DC voltage source of 5 volts minus the saturation voltage, okay, here, this one, and then we get 4.4 volts. We're going to divide it by the current on the base current, okay, and the base current, it's the collector current divided by the gain. This collector current, I set the value of 50 milliamps, of 500 milliamps, okay. We divide it by the gain, 50, and then we get the current for 10.01 amps. Okay, so now we just divide this voltage by the current, and then we get 440 ohms. But we are going to use a commercial value of 470 ohms. Okay, now that we have these values, we can do our simulation. So here we have the Simulink, the multisim. Okay, so here is the transistor. Here is the voltage, the DC voltage source for the LED. We have here the 330 ohms resistor for the LED. It's connected to the emitter of the transistor. The collector, no, to the collector, I'm sorry. The emitter is connected to ground. Then we have here the resistance for the base of the transistor, which is 470 ohms. And here we have the voltage source. This could be a microcontroller or anything, okay? And here I just put a switch, okay? So for example, so this is going to be like our microcontroller, okay? Because it gives a 0 or a 1. It means a 0 volts or 5 ohm or 5 volts, okay? So this is going to be as our microcontroller, okay? So let's run the simulation. Oh, I'm sorry. Okay. So it's running. We see here that our LED is on. If I press the switch, it's going to turn off, okay? So here the transistor is in pulse mode, okay? It's acting as a switch because there is a voltage, there is a current flow here, but there is not current flow through the transistor, okay? So it's an open circuit right now. So when I press again, there is a closed circuit, so there is current flow through this circuit, okay? Let's take a look at the values to see if we are right. Okay, the voltage for the LED it's 1.83 volts. This is because this LED it has this value in multisim, okay? So that's why it doesn't give us the 2 volts that we just found on the datasheet. Let's take a look now at the current. Okay, 27 milliamps. That's what we found. Okay. Let's take a look at the voltage across the resistor. There is this. There must be a drop of the voltage because of this LED. Okay, here we have the voltage drop. Oh, let's stop. This is not right. This is not okay. To take a look at the voltage drop, here. Okay, here. 7, because it's 2 volts LED. Okay, so 9 minus the 2 volts, we have 7 volts. Okay, and now let's take a look at the voltage, the base emitter voltage. Okay, here we have 793 millivolts. On the data sheet, we found that the saturation voltage is the minimum for the saturation voltage is this 0.6 volts. Okay, so it's correct. So that's why it is acting as a switch. Okay, so now let's take a look at the current. The current through the base current is 10 milliamps. Okay, so that's what we found here. Here you take a look. Okay, that's it. Okay, that's how a transistor works as a switch. Thank you.